Hey guys, welcome back to my channel, and it's been a while because I was busy with my relocation and home search, but now I'm all done and I'm back with a new question. So without wasting any time, let's directly dive into this question, which is question number 268, missing numbers. This is an easy level question. So let's see what this question is all about. So the question says that we are provided with an array nums which contains n distinct numbers from range 0 to n, and we have to return the only number in the range that is missing from this array. So first thing is we are provided with an array and there are numbers present from range 0 to n. Now what is n? N is equivalent to the length of the array, which is given in the constraints of this question. So here it is given. And all the nums are going to be unique. All the numbers in the array nums are going to be unique. So now what we have to do is we need to search this array and find that one number which is missing in this particular range. So there are so many ways of solving this question. So let's see how we can solve this question. So let's try to understand this whole problem using this example. So where we can see that the largest number is 5 and the length of this array is also 5, right? So we know that 5 is n, or n is equivalent to 5. So now we need to find a missing number. So the first approach that comes in our brain is let's sort this array, and then we will be easily able to find the number which is missing, as the numbers are in a kind of increasing order. So if any one of the number is missing, we will right away return it, and that will be the answer, which is correct. So if I'm going to sort this array, it will look something like 0, 1, 3, 4, 5, right? And I will traverse this array and I can see that from 0 to 5, 2 is missing. So I will right away return 2. So this is first approach, that is sorting approach. And this approach will be of time complexity big O of n log n, because we are sorting the array, and space complexity will be big O of n or big O of 1 depending on the programming language. So space complexity will be big O of n or big O of 1 depending on the programming language that you are using. Because if you are using Python, so we know that Python sort function uses timsort, and timsort in worst case scenario uses big O of n space complexity. And similarly in C++ and Java, they are made with hybrid. The sort function is made with a hybrid combination of quick sort and sequential sort, and these will take different time complexity. So this space complexity completely depends on the programming language that you are working with. So this is the first approach, and this will be the time complexity. So let's quickly see the coding solution of this approach. So what I was saying is, firstly we will sort the array. So this is how we will be sorting it. So then I'm running a loop for I in range length of num. So, and what I'm saying is, as I have already sorted this array, so what I will be checking? I will be checking if I is not equivalent to nums I, right? And if this is not equivalent, then what I will be doing? I will be returning I. But there is one case that we need to consider, and that is, as we are considering length of num. So length of num will be 5 and we are using range function. So the loop is running from 0 to 4. But we know that 5 is also inclusive, as we can see in this example that 3 is included in array, right? So what we will do after this, if that number is not present in this array, then we know that this number will be the largest number. This number will be equivalent to n. And what is n? After running this loop, we know that I value will be equivalent to 4, right? 0 to 4. considering this considering the example that we just saw in this. So the value of I will be from 0 to 4. But as I am saying, if suppose 2 was present in this example, but I am saying for a minute just forget that 5 is present. Suppose 5 is the missing one and 2 was present in this array. Then what if we end traversing this whole array and at the end we know that 5 is not missing. So what we will do? We will simply return the length of the array. Or even rather than returning length, we can do I plus 1. Both will work. So let's try to submit this. And we can see this is accepted. This runtime and memory is not actual, so we can ignore this. Now let's see another approach for solving this question. So in this approach, what I am saying is we can create a hash set. We can create a hash set of this array. So hash set will be 3, 0, 1, 4 and 5. Hash set looks something like this, right? So this is the hash set. And what I am saying, now we will loop through an array from 0 to n, and we will check whether that number is present in our set or not. As soon as my loop reaches 2 and it will check in this hash set, it will return 2 as 2 is not present in this hash set. Why I used hash set only? Because we know that lookup time in hash set is big O of 1. As lookups in hash set are equivalent, takes big O of 1 time complexity, right? Internally, hash set uses hash table. So the time complexity will be big O of 1. That's why we are using hash set, and this is how the second approach will be. So what will be the time complexity of this approach? As we will be looping an array for and firstly we will be transforming our nums into a set, so it will take big O of n time. Then again we are looping through we are looping from 0 to n in order to find the one which is missing, so it will again take big O of n, so it will become 2 of big O of n, which will be equivalent to big O of n. Just bear with my handwriting. And so time complexity we know is big O of n, and as a hash set will take space and it will also be of big O of n. So time complexity is also big O of n and space complexity is also big O of n. So let's code this solution as well. So firstly we will make a num set which will be set of nums. After this, what I'm saying is for I in range, length of nums plus 1, because we know that the length is also included, the number is inclusive. So now what I'm saying is if I not in a num set, then simply return I. That's it. And we are always going to get an answer, but for the sake of authenticity, let's simply add a return statement. And now let's try to run this as well. Yep, this is also accepted. And now there is one more approach. Let me just clean this board and then we will check that as well. So the third approach, and the one that I like the most, is logical one. So we are already told that the array contains integer from 0 to n, right? And one integer is missing. One number is missing. So if we apply the logic, we can simply do one thing. That is, firstly we will add all the numbers from 0 to n or 1 to n. In this case it will be 1 plus 2 plus 3 plus 4 plus 5, and this will be equivalent to 9, 10, 15. Right? This is 15. And secondly, we will add the numbers in nums. So this will be 3 plus 0 plus 1 plus 4 plus 5. And this will be equivalent to 13. So if I am going to subtract 13 from 15, I will be getting 2. And 2 is the missing integer. So this is the logic, right? We can simply subtract the sum of all the integers present in num from all the integers in that range, and we will get the exact number that is missing in this array. So this was the third approach, and it will take time complexity of big O of n, because we are traversing this array to add it up, right, for obtaining the sum. And space complexity will be big O of 1. Now rather than adding up a loop from 0 to n for getting the expected sum, what we can do is we can use one formula, because we know that 1 plus 2 plus 3 up to n is equivalent to n into n plus 1 by 2, right? So we can use this formula and calculate the expected sum, which in this case was 15, and then we can run a loop for nums and obtain a sum which was 13, and then we will return the value which we are getting after subtracting. So this was the most efficient one, and logically as well this is a pretty straightforward question. So let's code this approach as well. So here will be the expected sum, which is, as we already discussed, length of nums into length of nums plus 1 divided by 2, and actual sum will be sum of all the integers present in num. And what we have to return? We have to return expected sum minus actual sum. And we can try to, I hope I hadn't done any typo. Okay. We can see this is also accepted. And yeah, so this was the question, an easy question which was solved via many approaches. All three of them were quite interesting ones and quite straightforward one. So this was today's video, and I hope this video was helpful for you all. And if you really find it helpful, then you can like this video, subscribe my channel, and I will soon come back with another video, and this time pretty soon rather than after 2 months. Till then, take care, keep messing with algorithms, and thanks for watching.